So hi everyone. So in this class we will be seeing the various mechanisms associated with enzymes action. We will be seeing what is an active site of an enzyme and what are the various mechanisms which are associated with enzyme action. So before going to the class, I just want to remind you with that of the lift story which I have said during the fundamentals. So in that I said the usage of lift can be associated with that of the function of an enzyme. It actually greatly decreases our energy usage as well as saves much more time. The same concept applies here in case of the enzyme also. So with this we just move on to the topic. So what is an active site of an enzyme? The active site of an enzyme is the one where the substrate can easily bind, and in this specific place where the reaction is going to take place and the enzyme substrate complex is going to get formed, and finally it is going to give rise to various kinds of products. This site is called as the active site, where the active reaction is being taking place. So this site is called as the active site of an enzyme. So what are the mechanisms by which the enzyme action is being carried out? The various mechanisms associated are the lowering of activation energy. This lowering of activation energy can be associated with the lift story. In that lift story, I said you are not going to use much of your energy for getting on to the lift. Same here, it decreases the activation energy of that substrate, and because of that the product formation is favored. The second one is it should favor the formation of a transition state. It should favor, the active site must favor a formation of a transition state. Then we have got various kinds of theories which are associated with the enzyme substrate interaction. And finally we will be seeing about the actual mechanisms which can induce the catalysis. This is what we are going to see in this topic now. First we are going to decrease the activation energy and we are going to favor the transition state. After this we will see what are the various theories which are being associated with the enzyme substrate interaction, and finally we are going to see the real actual mechanisms which are going to induce the catalysis. You take this graph. So in this graph, this point is the reactant. So reactant has got certain specific kind of an energy, certain specific kind of a potential energy. Okay, so whenever this reactant has to get converted into product, then it has to attain a much higher energy state called as the transition state. Okay, this reactant energy has to get elevated to a much higher energy level called as the transition state. So from this transition state the product formation is favored. Say for example, this energy of using the reactants, I mean the increasing the reactants from the normal state to that of the transition state, the difference between these two we call it as delta Gp. Suppose this reaction is a reversible reaction. Say for example, from the product you are getting the reactant. So what actually happens in this? The product has to get elevated to a state called as transition state, and it is from this transition state the reactants are going to get formed. Clear? Now let's suppose the increase from the energy level from the ground state to that of the transition state in case of product, the difference in that energy level is delta Gs. S is nothing but substrate. So, in this case the final thing is substrate, and in this case the final product is product. Okay. So, this difference is delta Gs and this difference is delta Gp. Okay. What is Gibbs free energy change? Delta G. Delta G is nothing but the difference between delta Gp and delta Gs. It is the Gibbs free energy change. Now you can clearly see in this, for this reactant to attain the transition state, the energy level requiring is much lower. Say for example 4. Whereas the energy level used for changing the products from ground state to that of the transition state in the reversible reaction is much higher. Say for example 10. So, normally which thing will be favored? You like to use minimal energy or maximal energy? You will try to use minimal energy for the product to form. So, in this case, if the difference delta Gp to that of delta Gs is in the negative range, then it favors the forward reaction. It means what? The value of delta Gs is much higher, 10. The value of delta Gp is lower, 4. Okay. So, what is the difference between these two? Minus 6. Okay. So, this minus 6, if the reaction is having the Gibbs free energy as minus 6, then it means the reaction is going to go in the forward direction from the reactant to product. You got the point?